On the corner of Ontario and C Streets, in Philadelphia's Kensington neighborhood, there is a patch of tile floor exposed to the weather. It belongs to no building, the walls are gone, the machines are gone. The name that once stretched across the facade of a factory complex spanning multiple city blocks has been scraped away, painted over, and finally demolished into rubble. Most people who walk past this corner have no idea what stood here. For over half a century, this was the headquarters of Philco, the company that put a radio in 1 out of every 3 American homes, hired the man who invented television, designed the transistor that powered the first high-speed computers, and built the consoles that carried Neil Armstrong's voice from the surface of the moon back to Houston. At its peak, Philco was worth hundreds of millions of dollars and employed thousands of people at this single site. Then it was sold to a car company. Then the car company sold it again. Then the name ended up on discount electronics at Kmart. The tile is still here. The company is not. And the question buried underneath is worth answering, because the story of Philco is the story of a company that touched nearly every major technology of the 20th century and still managed to disappear so completely that most people have never heard of it. The answer begins with a carbon arc lamp and a man named Thomas Spencer. You are watching Tech District, where we take apart the companies that built the electronic world, down to the circuit board and the engineer who designed it. If that is your kind of story, subscribe and hit like, because the rise here is just as strange as the fall. To understand Philco, you first have to understand Philadelphia in the 1890s and what the world was like before radio existed. This was a manufacturing city built on iron, textiles, and locomotives. Electricity was new, exciting, and mostly useless to the average person. The light bulb existed, but had not yet conquered the American home. There was no broadcast entertainment, no voices coming through the walls. If you wanted music, you either played it yourself or you paid someone to play it for you. If you wanted news, you waited for the morning paper. The idea that a wooden box in your living room could bring you the voice of a president or the sound of a baseball game was decades away from being real. The dominant form of electric illumination for streets and public spaces was the carbon arc lamp, a device that produced light by passing current through 2 carbon rods separated by a narrow gap. The arc was blindingly bright, dangerously hot, and required constant maintenance because the rods burned down and had to be replaced every few hours. But for a brief window in the early 1890s, before the incandescent bulb made it obsolete, there was money in making them. Thomas Spencer saw that money. In the spring of 1892, he and his brother Frank Spencer joined with a businessman named Frank S. Marr and 2 other associates to form the Spencer Company in Philadelphia. Their sole purpose was to manufacture carbon arc lamps. They purchased patent rights from the Helios Company of Germany, and later that same year renamed themselves Helios Electric Company, with Marr serving as president. The timing could not have been worse. The incandescent bulb was already eating into the arc lamp market by the time the ink was dry on the incorporation papers. And by 1893, Helios Electric Company was finished. It shut down operations entirely. For the next several years, the company existed only on paper, its assets eventually passing to the Helios Upton Company of New Jersey in 1899. Manufacturing did not resume until 1904. By that point, the original carbon arc business was dead. What the founders had left behind was not a product. It was a shell, a name, and a factory with nothing to build. What saved the company was not a new lamp, it was a new battery. On July 25, 1906, the remnants of Helios reorganized as the Philadelphia Storage Battery Company. The idea was simple enough: build storage batteries for electric automobiles, trucks, and mine locomotives. The first factory stood at Emerald and Tioga Streets in Philadelphia. It was a modest operation: 18 employees, 20,000 square feet of floor space, including the yard. 1 desk, 2 chairs, and a letterpress. Frank S. Marr remained president. By 1909, the company had outgrown Emerald and Tioga and moved to the corner of Ontario and C Streets in Kensington, the location that would serve as its headquarters for the next 65 years. The building that went up at Ontario and Arbor Streets became Plant Number 1. It was the first brick in what would eventually become an industrial complex stretching across an entire neighborhood. Marr died on December 1st, 1916. Edward Davis succeeded him as president, restructured the company, and opened stock options to executives. But the man who truly transformed Philadelphia Storage Battery Company was an engineer named James M. Skinner. Hired during the 19-teens, Skinner rose quickly, becoming vice president and general manager by 1919. He launched aggressive national advertising campaigns in publications like National Geographic, expanded the company's distribution network across the United States, Canada, Great Britain, and Argentina, and pushed the firm to adopt a new brand name. An internal contest was held, and engineer Donald T. McGregor won with the word Philco. The name first appeared as a trademark on a battery in 1919, though it would not become the company's legal name until 1940. Under Skinner's direction, Philco began supplying batteries to the infant radio industry that was just beginning to reach American living rooms. That decision set everything that followed in motion. The product that put Philco on the national map was called the Socket Power Battery Eliminator, developed under Skinner's direction and introduced in August 1925. Early home radios ran on storage batteries. They were bulky, expensive, and prone to leaking acid onto the furniture. The Socket Power was a rectifier that allowed a radio to draw power directly from a standard wall outlet. The irony was sharp even at the time. Philco's core business was selling batteries, and the Socket Power was a device that made batteries unnecessary. 1 million units sold by 1927. Philco had found its market. Then the market vanished. The invention of the alternating current vacuum tube rendered the battery eliminator obsolete almost overnight. The product that had made Philco relevant was suddenly worthless, and the company teetered toward bankruptcy for the second time in its life. James M. Skinner's response to this crisis defined everything Philco would become. If the company could no longer sell the battery, it would sell the radio itself. In 1928, Philco entered radio manufacturing. 96,000 radios rolled off the production line in the second half of that year alone, placing the company 26th among roughly 800 radio manufacturers in the United States. That ranking did not last. Skinner borrowed $7 million to retool the Ontario and C Streets plant for automobile-style assembly line production, a method no radio manufacturer had ever attempted. The bet was enormous. The country was sliding into the worst economic depression in its history, and Skinner was borrowing millions to mass-produce a consumer product. But the logic held. Radios were entertainment, and entertainment was the one thing Depression-era families were still willing to buy. If Philco could build radios cheaper and faster than anyone else, the Depression would become the tailwind, not the headwind. By 1929, Philco had climbed to third place behind Atwater Kent and Majestic. The bet paid off in full in August of 1930, 10 months after the stock market crash, when Philco introduced the Model 20, which the public quickly nicknamed the Baby Grand. It was a compact tabletop radio housed in a cathedral-shaped wooden cabinet designed by Ed Combs. Inside sat a 7-tube screen grid chassis with an electrodynamic speaker. The price was $49.50 without tubes, $68 with them. At a time when the market leader, Atwater Kent, sold handcrafted console radios for well over $100, the Baby Grand was a fundamentally different product. It looked beautiful, with the soft arched lines of a Gothic window. It sounded clear, and a working family in the teeth of the Depression could afford it. Over 300,000 units sold in its initial production run. By the end of 1930, Philco had moved 600,000 radios, grossed $34 million in revenue, and claimed the #1 position in the American radio industry. The company would hold that position for more than 2 decades. Skinner also hired industrial designer Norman Bell Geddes to create the cabinets for Philco's higher-end models. In 1931, Philco struck a promotional deal with Paramount Pictures, placing radios in theater lobbies across the country and distributing autographed photographs of Paramount stars. By 1934, Philco controlled 30% of all domestic radio sales, producing 1.25 million sets per year. That was twice the output of RCA. A 1936 article in Time noted that under Skinner's leadership, Philco was making twice as many radios as its nearest competitor. Skinner's goal at the time was 6,000 radios a day. He got it. The same year Philco conquered the radio market, a young inventor from Utah named Philo Farnsworth was demonstrating electronic television in San Francisco. Philco would soon bring him to Philadelphia. That decision and what followed from it would set the pattern for every missed opportunity in the company's future. Then came the war. After Pearl Harbor in December 1941, Philco converted its manufacturing facilities to military production. The company built radar equipment, radios for tanks, frequency meters, proximity fuses for artillery shells, and plexiglass canopies for American aircraft. Philco's Washington office opened specifically to pursue military contracts, and when a competing electronics firm told an Army Air Corps colonel that it would take 8 months to get radar into production, Philco examined the same device, brought a sample back to the Kensington plant, and promised 2 working units by January 1942 with full production starting in 8 weeks. They delivered. Revenue in 1942 reached $68.5 million, the vast majority of it from government contracts. The conversion cost something, too. Philco's profits dipped to $2.2 million that year, and the company absorbed a loss of over $1 million on civilian inventories, rendered worthless by the halt of consumer production. But Philco proved that its assembly line methods, the same techniques Skinner had borrowed from the automobile industry to build cheap radios, could produce military hardware at speed and at scale. That capability would matter again, decades later, in a very different context. After the war, Philco turned its ambition toward television. The company had been experimenting with the technology since the early 1930s, when it established experimental broadcasting station W3XE in Philadelphia in 1932. By 1936, Philco engineers had demonstrated prototype receivers displaying 441-line images, including outdoor broadcasts from the ballroom of the Germantown Cricket Club in Philadelphia. The war had delayed consumer production, but by 1947, Philco was building compact tabletop television sets with screens of 6 to 8 inches, and by 1949, the company had produced 800,000 of them. Orders were still coming in faster than the factory could fill them. This was the golden age. Philco produced its 10 millionth radio on November 21, 1937, a Model 38 116XX that rolled off the line at the Kensington plant. By 1950, annual sales had reached $335 million. The factory complex at Ontario and C Streets had expanded across multiple city blocks along Ontario, C, Tioga, and Allegheny, employing thousands of workers in what amounted to a company district within a city. The Philco name appeared on radios, televisions, refrigerators, air conditioners, and phonographs. Distributors attended annual cruises to Bermuda, where the company unveiled the next year's product lineup in a private presentation at sea. The brand was not merely popular, it was embedded in American domestic life. The Model 20 Baby Grand was the product that earned that position, and the affection it inspired has outlasted the company itself. That cathedral-shaped cabinet sat in living rooms from Philadelphia to Portland, and for millions of Americans during the Depression, it was the first radio their family ever owned. The 7-tube chassis was not the most powerful on the market, but it did not need to be. It needed to work, it needed to sound good, and it needed to cost less than $50. It did all three. Families gathered around it on weekday evenings to hear Franklin Roosevelt's fireside chats, on Saturday nights for the Grand Ole Opry, and on Sunday afternoons for baseball. The cathedral's shape became so identified with the idea of a home radio that other manufacturers rushed to copy it. Over 2 million cathedral-style Philco radios were sold across the production run from 1930 to 1938, and the community that restores them today is large enough to sustain online forums, dedicated parts suppliers, and annual conventions. Working units still change hands at antique radio shows for $50 to $300 depending on condition. The Baby Grand did not just sell well, it survived. The second product that defined Philco was the one that nearly ended the company. In 1958, Philco debuted the Predicta, a television set promoted as the TV of tomorrow. The design separated the picture tube from the receiver chassis for the first time in a production television. The screen sat on a swivel, mounted atop a slender pedestal, and could be rotated to face the viewer from any angle in the room. The pedestal model sold for $269.95. A higher-end version called the Penthouse connected the screen to the base with a 25-foot flexible extension cable and sold for $339.95. The design team included Catherine Winkler, one of the few women working in Philco's industrial design department during the 1950s, along with Severin Jonassen and Richard Whipple. Winkler is largely absent from the standard histories of industrial design, even though she co-designed what would become the most sought-after television set in the American collector market. She is also believed to have designed the Old Spice sailing ship logo, though that attribution remains informal. Collectors gave the Predicta affectionate nicknames. They called the pedestal the gas pump. The console version became the barber pole. The tabletop model earned the name the Cyclops. The problem was timing. The Predicta was a black and white television launched at the precise moment color broadcasting was beginning to take hold. The semi-flat picture tube proved unreliable, driving up warranty service costs. Sales fell. Philco discontinued the Predicta after just 2 production years. The last unsold units were liquidated in block sales to motel chains, where they sat in rooms across the country, watched by travelers who had no idea they were looking at a collector's item in the making. Today, a restored Predicta in working condition sells for north of $3,500, and the design still looks like it belongs to the next century, not the last one. Between the Baby Grand and the Predicta, Philco had already made the most consequential personnel decision in its history, and handled it the worst. In June 1931, Philo Farnsworth, the inventor of electronic television, left his Green Street laboratory in San Francisco and accepted a position at Philco in Philadelphia. Philco wanted to enter television, and Farnsworth was the most important television engineer alive. He set up a research division at the plant, conducted experimental over-the-air broadcasts through station W3XE, and continued refining his image dissector. His young son, Philo III, became one of the first children in America to watch television at home when the Disney cartoon Steamboat Willie was screened through the Philco Labs film chain and transmitted to a prototype receiver in the Farnsworth living room. The advancements Farnsworth worked out during his time at Philco included the sawtooth wave, a horizontal blanking action that eliminated blur and ghosting from the television image. But Farnsworth grew increasingly frustrated by management constraints and the limits placed on his work. In 1933, he left to establish his own company. Philco had employed the inventor of television for 2 years and let him walk away. That pattern, the pattern of reaching the future and then pulling back, was about to repeat itself with even greater consequences. In 1953, Philco engineers invented the surface barrier transistor, the first transistor fast enough for use in high-speed digital computers. MIT's Lincoln Laboratory used Philco transistors to build the TX0, one of the earliest transistorized general-purpose computers ever constructed. Philco itself built the Transac S2000 in 1957, the first large-scale, fully transistorized scientific computer offered commercially by any manufacturer. 3 technologies that would define the second half of the 20th century, television, the transistor, and the computer, had all passed through Philco's engineering labs. and Philco was about to lose all three of them. The 1950s should have been the decade Philco chose a lane. Instead, Philco chose every lane at once. The company was building radios, televisions, refrigerators, air conditioners, washing machines, dryers, and electric ranges. In 1954, it acquired both the Bendix Home Appliances division and the Crosley Company to add laundry equipment and expand its refrigerator lines. It opened Philco Italia to establish a foothold in continental Europe. It poured money into the computer division, and it watched year by year as the money ran out. The surface barrier transistor was, by any engineering measure, a triumph. Philco's process used indium sulfate to etch circular depressions in germanium, then electroplated indium into those depressions to form the transistor electrodes. The resulting device was fast enough that the National Security Agency awarded Philco the contract for Project Solo in 1955, which produced what the NSA considered the world's first fully transistorized large-scale electronic computer. Philco licensed the transistor technology to companies across Europe and the United States, including Plessey in Britain and General Transistor Corporation in America. MIT used Philco surface barrier transistors in the TX-0 computer, which was a direct ancestor of the machines that would eventually become Digital Equipment Corporation's PDP line. Philco had built the component that made high-speed computing possible. The transistor they invented became the seed of a digital revolution they would never profit from. But the Transac S2000, Philco's own commercial computer, could not compete with IBM. The development costs were staggering, and IBM's sales force and service network were entrenched in every major corporation and government agency in the country. The computer division drained capital from the consumer electronics divisions, which were themselves under pressure from Japanese imports and low-cost domestic competitors. Earnings tell the story without mercy. In 1950, Philco's annual sales stood at $335 million. By 1960, earnings had collapsed to $2.3 million. In the first half of 1961, the company posted a loss of $4.4 million on sales of $196 million. Too many product lines. Too little capital concentrated on any single one. The company that invented the fast transistor sat and watched while IBM built the computer industry on top of it. By the autumn of 1961, Philco was looking for a buyer. Ford Motor Company, under Henry Ford II, was looking for diversification beyond the automobile business. Ford wanted Philco's defense contracts, its transistor expertise, and its consumer electronics brand to compete with General Motors' appliance divisions. In September 1961, Ford announced its intent to acquire Philco through a stock exchange valued at approximately $100 million. The deal closed on December 11, 1961. A Time magazine article covering the merger noted that Philco had received $53 million in defense contracts in the preceding 6 months alone, mostly for missile guidance systems, and that Ford planned to operate Philco as a semi-autonomous subsidiary with no major management shakeups. James M. Skinner Jr., the son of the man who had built the company, had been made president in 1956 in the hope that he could reverse the decline his father's successors had allowed. He tried to institute reforms. It was too late. Ford renamed the subsidiary Philco Ford in 1966 and merged it with its own aeroneutronic division. What followed was a strange and brilliant epilogue. In 1963, Philco Ford went head-to-head against IBM, RCA, Lockheed, Hughes Aircraft, and AT&T in a bid to build the Mission Control Center at NASA's new Manned Spacecraft Center in Houston. Philco Ford was the underdog. It won. As prime contractor, Philco Ford designed the command consoles, installed over 60,000 miles of wiring for real-time voice and data transmission, and integrated telemetry systems capable of processing more than 1,500 data streams at once, covering everything from astronaut vital signs to spacecraft performance. The facility was operational by 1965 in time for Gemini 3, and Philco Ford maintained it through the entire Apollo program. On July 20th, 1969, when Neil Armstrong radioed from the lunar surface, his voice traveled through equipment built by engineers working under the Philco Ford name. Walter LeBurge, the manager of Philco Ford's Houston operations, later noted that without the merger with Ford, the company would never have been considered for the job. Because of the sheer magnitude of engineering resources required, the consoles that guided Apollo 11 to the moon were built by a company that had started making carbon arc lamps in 1892. That fact deserves a moment. But the consumer brand was dying. Japanese imports and Taiwanese manufacturing eroded what remained of Philco's domestic electronics business. Ford began importing Philco-branded products from its own subsidiary in Taiwan. The Philadelphia factory complex, the one that had stretched across city block after city block in Kensington, began to shrink. Ford sold Philco to GTE Sylvania in 1974. There was a bitter irony in that transaction. When Philco had first begun selling radio tubes under its own brand name decades earlier, those tubes had actually been manufactured by Sylvania. Now, Sylvania owned the company that had once been its biggest customer. The Kensington plant closed in the early 1980s, and over the following years, the buildings were demolished one by one. In 1981, Philips acquired Sylvania Electric Products, and with it, the Philco brand name, gaining the right to use the Philco trademark in the United States. Philips had created its own brand, Norelco, specifically to avoid confusion with the similarly spelled Philco. Now, it owned both names. The company that had once led the American radio industry had been reduced to a licensing agreement. For a few years, the Philco name appeared on value-priced televisions and clock radios sold at Kmart. Then, it appeared on nostalgia-themed record players marketed under license by Polyconcept USA. Then, those disappeared from shelves too. The value destruction is easier to understand in numbers. A company generating $335 million in annual sales in 1950 was sold to Ford for roughly $100 million in 1961. Ford sold it to GTE for less. Philips bought the trademark from GTE for the right to print it on products made by someone else. The factory site in Kensington, the place where the Baby Grand, the Predicta, and the surface barrier transistor were all created, is now an empty lot. One building survived longer than the rest. Building 14, the old cabinet factory, where workers once shaped the wooden enclosures for Philco radios, stood as the last remnant of the complex. Historian Ron Ramirez spent 23 years documenting Philco's history, traveling repeatedly to Philadelphia, photographing what remained, and assembling what he described as the most comprehensive record of the company ever written. In 2002, he stood on the last surviving piece of tile from what had been Philco's 1945 radio phonograph factory. The building behind him may have been the old Plant 2 chassis, works on Allegheny Avenue. He was not certain. There was not enough left to tell. But the machines survive. Model 20, Baby Grands still change hands at antique radio shows, and the collectors who restore them can recite the tube lineup from memory. Predicta televisions sell for thousands of dollars to buyers who want a piece of what television almost became. Philco surface barrier transistors sit encased in lucite keychains. Sold as curiosities by vintage electronics dealers, small monuments to the component that made high-speed computing possible. The transistors Philco invented powered the TX-0 at MIT, and the TX-0 was a direct ancestor of the machines that led to the personal computer. Ford Aerospace, the entity that grew out of Philco Ford's defense division, built more than half the communication satellites in orbit by 1980, before Ford sold it to Loral Corporation in 1990. The Philco Ford name was gone, but the engineering lived on in orbit, carrying signals across oceans long after the factory that built the first transistor had been torn down. James M. Skinner, the engineer who drove Philco from a dying battery maker to the largest radio manufacturer in the world, has never been inducted into the Consumer Electronics Hall of Fame. His contemporaries, David Sarnoff at RCA, Arthur Atwater Kent, Powell Crossley, have all received the recognition. Skinner has not. Ron Ramirez, the historian who devoted over 2 decades to the Philco record, has called it an injustice. The documented history supports him. Skinner built the assembly line radio industry, priced the American family into the electronic age, and led the company that held the #1 position in radio sales for more than 20 consecutive years. The industry he helped create moved on without remembering his name. On the corner of Ontario and C Streets in Philadelphia's Kensington neighborhood, a patch of tile floor sits open to the weather. It held the weight of the cabinet makers who shaped the baby grand. It held the drafting tables where Catherine Winkler drew the television of the future. It held the workbenches where Philco engineers etched germanium to build the fastest transistor in the world. It once carried the hum of assembly lines running 6,000 radios a day. Now it carries nothing. The tile is still there. The company is not. Philco built the future 3 times over and each time chose the past instead. If you owned a Philco, worked on one, or worked at the plant on C and Tioga Streets, drop a comment below. Tell us the model, the year, and whether it still runs. The people who use these machines and the people who built them know more about what was lost than the people who sold it. Subscribe because we have the story of another American tech empire coming next, and you will not want to miss how it ends. The channel is Tech District.